Determine the gravitational acceleration on the surface of the moon if its mass is 1/32 of the mass of the Earth and its radius is 1/4 that of the Earth. Take ME and RE as the mass and radius of the Earth, respectively. Now, this comes from Newton's law of gravitation. And what is Newton's law of gravitation? It says that when we have two masses, M1 and M2, separated by a distance r, then the force of attraction between the two masses is given by F is equal to G M1 M2 all over r squared, where G is a constant known as gravitation constant. Now, in this formula, the masses are in kilograms and the distance is in meters. And this G, gravitation constant, has been found from experiments to be 6.7 times 10 raised to the power minus 11 Newton meter squared per kilogram squared. All right, so we have G, gravitational constant, but our problem is asking us to find the gravitational acceleration on the surface of the moon. So we can use this Newton's law to form a relation between gravitational constant and gravitational acceleration. So how are we going to do it? Now let's assume a mass m on the surface of the Earth. Now, if we assume that the density of the Earth is uniform, we can say that the mass of the Earth will be concentrated at the center of the Earth, which is zero. Which is zero again, O rather. And then the distance between that mass on the surface of the Earth and the center of the Earth is r, let's say radius of the Earth in this situation. So if we apply this Newton's law of gravitation here, a mass on the surface of the Earth, mass of the Earth, distance r between the two of them, because the mass of the Earth will be concentrated in the center, we can say that the force between them is G M1 M2 over r squared. But then, for a body on the surface of the Earth, we know that M, the force of it will be M, force on that body will be mg, right? Force, mass and acceleration. This is mass and acceleration due to gravity. But then, from Newton's law of gravitation, we can also say that this force is G M as mass of the Earth, mass of the body, all over r squared. So if we just think about this part here, we can say that this m will cancel out this m. So we have G is equal to Gm all over r squared. So basically, the gravitational acceleration on a body on the surface of the Earth is equal to gravitational constant times the mass of the Earth over radius of the Earth, right? So if we take that same thinking and extrapolate it to like mass, let's say this is the moon too. The moon also, we can assume the moon to be a sphere similar to the Earth, right? We can also say that in this case, right, gravity on the Earth is G M mass of the Earth over r e squared, right? So in the case of the moon, the gravitational acceleration of the moon will be G M will be equal to gravitational constant, mass of the moon all over radius of the moon squared. But in our problem, we're not given the mass of the moon and radius of the moon. Instead, we're given that we should take the mass of the moon to be 1 over 32 of the mass of the Earth. So mass of the moon is equal to 1 over 32 mass of the Earth, and radius of the moon is 1/4 that of Earth. And so what we're going to do here is just substitute these values into this value to find the gravitational acceleration on the surface of the moon. So that gives us Gm will be equal to G 1 over 32 me all over 1 over 2 re squared. Okay, so this is 1 over 4 rather. 1/4 radius of the moon is 1/4 radius of the Earth. So this is 1 over 4 here, right? So if we simplify this, we're going to get GME all over 32 dot RE squared, and this 4 squared will go up, but that's 16, right? So if we simplify further here to G, gravity on the moon will be equal to GME all over 2RE squared, right? So if we compare that to this, we can say that the gravity of the Earth, gravity on the moon is half the gravity of the Earth, right? We've actually resolved our problem, and we can say that the gravity on the moon is GME over 2RE squared, and that's is C.